Hello all, welcome to the subject of VLSI, Design and Technology. This is Professor Meenakshi Pancha from Electronics and Telecommunication Department, Parvatibai Ganba, Mujhe College of Engineering. In the previous lecture, we have discussed till the designing of HDL. We have seen that the HDL structure will contain these major components. One is library, second one is entity, and third one is a architecture. We have seen in a detail in the previous lecture. So today we will begin with the small. Today in this lecture we will begin with the how the entity will be declared and what are the ports for declaring the entity will be used. This is the entity declaration. In this slide, the figure have shown. This is the figure of half adder. Here, the half adder figure is given here, and that entity, this information will be mentioned in the entity. Here, this is the entity half adder is, which is having port A, B, means which is having A, B are in, and these are bit. Not, nothing but what are the types of the input getting in this A, B terminal. Here we have mentioned it's a bit, semicolon, and sum. Sum, comma, carry is the output. Here sum and carry are the output signal or output terminals are there. We have mentioned in the program. And we have mentioned that this sum and carry are the output terminal by using out. And what are the types of output signal we will obtain? Here the bit type of signal will be obtained at the output terminal of sum and carry, which is mentioned in the entity. So while starting with the entity which contains all the information about input and output which is used in the application. So here the word entity should be used before starting the entity or before begin to construct the entity. Here entity word will be used, and then the name should be used. This name is a user selected name. So we are seeing the operations of half adder here. So we have taken half adder, half underscore adder. The name of the entity should be follow underscore sign, and is also predefined word. So entity of half adder is, then we should start from port. So what are the ports, input output terminals we are using? So that we are seeing here A and B, these two are here A and B, these two are in bit type input terminals we are having, and sum and carry, these two are output bit type signals we are getting in this two terminals. So after declaring the port information, and word should be used, and is also predefined word, and with the name followed by the entity, we should end the entity by name. So end half adder semicolon. So this is the entity declaration. Here we are taking the ports A and B are in, and sum and carry are out. Except in and out, there are other few ports are there. Here we have mentioned that in, out, buffer, and in out. These are ports which can take the mode according to our entity. How we are going to define it? See one by one. What are the in? The port in is only as an input. Where we are using in, when this port is only we are using for input. We are not getting output from this terminal. This pin, this A terminal, we are only using for input. Hence, we are using in. In any assignment statement, the port should appear only on the right hand side of the statement. Always the port should be on the right hand side of the statement. Then out. The out port is only an output port. Out port, this port is only used for output port. In any assignment statement, the port should be appear only left hand side of the statement. This output should be left hand side of the statement. So these out is nothing but this terminal only used for the output purpose. Other than that, there is a buffer is also there. This buffer port can also used as both input and output, but it can have only one source. See here, the buffer when we used when the terminal which we, for example, if any circuitry is there, if there any circuitry we are assuming if any circuitry is there, we are using. So the output of one is using for input. The output of one terminal is using input. So such type of organization. So we are using buffer. Buffer is nothing but this port which contains both output and input both. But it can have only one source is there. The port can appear on either left side, right side and left side of the assignment statement. A buffer port can only be connected to other buffer port or to a signal that also has only one source. Then next, in out. What are the in out? The port can be used as both input and output. This is also. This one also. This port can be used as both input and output. These are the ports we are using in HDL designing. So, in the next slide, we will see the operators. The operators of HDL. What types of operators are there? The VHDL has an extensive list of the operator, and these operators are used extensively in every perform or variety of the functions. These functions can be classified. How they are classified? These functions can be classified as logical, relational, arithmetic, and shift. So such type of operators are available in the HDL. So we will see one by one. What are the logical operators? The logical operator which performs the logical operations. What are the logical operations? AND operation, OR operation, NAND operation, NOT operation, and non-operation exclusive OR operation. So such type of operations can be on two operands or on single operands. So such type of operations will be performed on two operands or two operands or on single operands. So such type of operation will be performed and the operands can be single bit or multiple bit. Here in the table, we will show the operators of the VHDL logical operators. Those operators should appear only on the right hand side of the statement. These should be only on the right hand side of the statement. For example, if if I am doing some AND operation. So here Z is my output, here Z is my output, and I am performing AND operation. AND operation of A and B. There are two terminals in the AND operation A and B. Output is 1. So in logical operation, operator should be appear always appear on the right hand side of the assignment operator. This is the assignment operator. So always these logical operator should be lies on the right hand side of the assignment operator. Here to perform this AND operation, these are the two input pins and this is output terminal. So A and B is which performs AND operation in the program. To perform AND operation, we have to write the code A and D AND. So we have to write like that A and B. So A and B and the result will be stored in set. So this is AND operation. For writing or A or B, we should write like this, which will perform the logical OR operation. Similarly, A, NAND, B should be used to perform the NAND operation. This is the NAND operation. A and B is to input terminal and output we will get like A dot B underscore set. We will store it into the set. So A NAND B, we have to write such type of code. To perform NOR operation, A NOR B should be used, and to XOR operation, to perform the XOR operation, A XOR B code should be right, and to perform the XNOR operation, A XNOR B should be like that. To perform the NAND or NOT operation, to perform the NOT operation, here only one input and one output terminal is there. A and the output is A bar. So we have to write NOT dot. Dot command is used to perform a dot operation. These are the few logical operators. So let's see further. So now we will see some relational operators. These operators, the relational operators are implemented to compare the values of two objects. Always the relational operators are implemented to compare the two objects. And the result returned by these operators is a Boolean. That is false or true. Always relation operator result is in the form of the Boolean. So let's see some of the relational operators of the HDL. Here we are shown in the figure. For assigning the equal relation, we will use this sign. For example, if we are writing command like if A equal to B, we are going to compare two objects or two values. Then so the further command will be going to execute when if A is equal to B. So comparing these two objects, equality, we are going to compare equality of these two objects. So equal to sign will be used. If not equal to, then this operator will be used. For less than, if A less than B. So such type of symbol will be used for comparing these two object A and B. If A is less than B, then the further command will be going to execute. If less than or equal to, for less than or equal to, if A is less than or equal to B, then the further command is going to execute. So it will compare the object A is equal or less than B. If this, no. For example, we are assuming that A holds some value and B holds the some values, C holds some values. So this operator less than or equal to operator will be used when if condition we are using if A is less than or equal to B. If the value of these two objects are equal or A will be less than B. On such condition, the further command will be going to execute. So these type of comparing, relational comparing, these operators are used for less than or equal to. For greater operator, if A is greater than B, in this command, the greater symbol will be used to compare these two objects. If the value of A is greater than B, then only the further command will be going to execute. So then next, if A is greater or equal to B. So similarly, the greater than or equal to operator will be used for comparing these two objects. In this object, the value of A is greater than B or equal to B. So checking these two conditions, if for example A holds 5 and B also holds 5, here one condition fail. A is not equal to B. But here other equal operation equal sign is also there. Here it will check if the value of A is equal to value of B, as these two having same value, which holds these two operators hold same value. So in this condition the statement will become true and it will going to execute the further command. So such type of comparing the objects, the these type of the relation objects are operators are used. One is equal to for comparing equality, it's not equal to, less than, less than or equal to, greater than or equal to. So these are the operators used in the coding or in the programming to perform equality functions or assigning some operators. Here for example, this is the assignment, how we are going to assign here. We are going to assigning like this. It's one of the small example. And these are some arithmetic operators we are used to perform some arithmetic operations of different objects. Here, the plus sign will be used for assigning addition operation. Here, the two terminals or two bits is there, A and B. To perform the addition operation A and B, plus sign will be used in a HDL programming. Arithmetic operators can perform a wide variety of operations such as addition, subtraction, division, and arithmetic operator operates on numeric and physical operands types, and the data type are those that can be measured in a unit and time. Here some of the operators, arithmetic operators have mentioned in the slide. Here to perform arithmetic operation of two different objects A and B, the plus sign will be used. And similarly, if A and B are these two are numeric type, then data output will get numeric. And similarly, the minus sign will be used for subtraction operation. And what are the input of A and B? That is the output of the and multiplication here. So the star symbol will be used for multiplication here. What are the type of input here? A is an integer or it may be real, and B also integer or real. The answer will be get as same as the A. What are the type of the A input is there? That type of the output we will get. And similarly here also, what are the input is there? So that such type of output we will get. The performing division operation. Here A divide B, this symbol will be used, and an integer or it may be real, or B is an integer or it may be real. The output is also always A type, and similarly in this, if A is an integer or real and B is a physical, then the output will always physical type. So MOD, the mode command will be used for performing modulus operation. So we should write like that A mod B. Here A is an integer type and B is also integer type. Then output will also get a integer form. If we have to check remainder of A and B, these two things. So A REM remand B. So such type of code will be used for checking the remainder produced in this using by this objective. So A and B both are in integer form, their output is also available in the form of integer only. So similarly the absolute operations A B S bracket A to check the absolute of numeric A, then always output will be in a positive form. To form AND or concatenation operation, so we have to write like A and B. So A is a numeric and B is a numeric array. Then same output available in the form of A type, which is numeric and array. And similarly, exponent operation will be we can perform A double star. Here double star will be used to perform exponent operation. So A double star B. Here is nothing but A is a form of real and integer, and B should only in the form of integer only. Then the output will be available in the form of, or we will going to get in the form of A, whatever the data type of A. So these are the some arithmetic operations, and these are the symbols or codes we are using to perform such type of operations in a programming. These are the some shift operators. The shift and rotate operators are implemented in many applications, such as multiplication and division. The shift left represents the multiplication by 2 and shift right represents the division by 2. The VHDL shift operators are discussed in this figure. Here shift operators are unary operators and they operate on single operand, and to understand the function of these operators, assume that operator A and B bit vector. So here some of the shift operators. To perform these shift operations, such type of command we should use, which is mentioned in here table. Here these are the operations and descriptions is there. If the data A contains, if the data A, the A which contains the data 1110, I want to perform 1 bit shift operations here, then I should write like A S L L 1 is nothing but shift A 1 position left logic. Shift A 1 position left logic. Such type of command should be used in the programming. Here 1110 is there. Left. Here left in the direction of left. The 1 bit is going to shift here. Here the 1 bit is going to shift. So this 0 will become here. Here. This was 1110. And how we are going to get here? This 0 is going to shift here. Then this is the unknown bit now. 110 x. So here the 0 coming here, the each bits are going to shift to left. Similarly, shift a 2 positions left logic. I want to shift 2 position. Then what will going to here shift, see here, directly 2 position. It will come here. Then what will get output? 10 here. 0 and 1. This type of shift operation. So this code will be used for performing shift operation. Similarly, ASRL dot 1 is shift A 1 position right logic here. So each bits are going to shift 1 position at the right. Here the 0 will be go out. This 1 is come here. It will become 1. And this 1 is come here. This 1 is come here. So here these 3 bits are going to shift to right. So 111 is getting. Similarly, to shift a 2 position right logic. Here 2 position will be going to shift here. So to perform a shift operation at the right side, so SRL 1 bit shift. SRL 2 is 2 bit shift. ASLA 1 is nothing but shift 1 position left arithmetic. So shift always 1 position left arithmetic. Only 1 position will be going to shift here. And SRA shift a 1 bit right arithmetic. Here 1 bit is going to shift at the right here like this. To rotate 1 position left. Here this is the difference between shift and rotate. What will happen in the rotate? Rotate it will happen 1101. Rotate is nothing but 1 position left. Rotate is nothing but this 1 come here and this 0 come here. So such operation will be going here. This 1 come back and such type of operation will be performed. Now rotate. Rotate a 1 position right. So at the right side, 1 position will be going to rotate here. See, this 0 come here, this 1 come here, and this one is come here, this one is come here. So this will come like a 0, 1, 1, 1. Here the right side, one position will be going to rotate. So these are the some operators we are using with such type of operations like shift and rotate. So today we have seen that the operators like arithmetic, logical and shift operators we have seen. Now we should discuss about what are the data types. So the whole detail about the data types. What are the type of the data? What are the input type data? And what type of output we will get? So all these things we will discuss in the next lecture.